Hello there and welcome to this brand new video. If this is your first time on this channel, this is Hap Beyond Numbers, where we learn maths the easy way. Now, in this video, we'll be looking at equivalent fractions. And I do hope that the introduction to fractions in the previous video has been very helpful. Talking of equivalent fraction, let's look at this scenario. So let's say you buy pizza and then you choose to divide it into two equal parts and take one of it. Now you can imagine what you'd have left. You would have exactly half of it left. What if someone also decides to buy the same brand of pizza, but then divides it into four equal parts and take just two of it? You realize that the remainder would be the same. If you think otherwise, let me know at the comment section. Now that brings us to what we call equivalent fractions. That brings us to the idea of equivalent fractions. So when I say equivalent fractions, they are fractions that represent the same part of a whole, even though they may look different. Let me write that out. So as we have said, these are fractions that represent the same part of a whole, even if they look what? Different. With that in mind, let's look at some visualizations so we understand well what equivalent fractions are and so we can appreciate. So let's draw out two circles. I'm going to draw this first circle here. And I'll copy that same circle and then paste it. Now on these two circles, we are going to illustrate what equivalent fractions are. So for these two circles, on the first one, I'm just going to divide it into two equal parts. So as you can see here, we have it divided into what? Two equal parts. On the second one, I'm going to divide it into four equal parts. Now on the very first one, let's just take a portion of it. So on the first one, I'm just going to take one portion of it. As you see here, we have just one portion. Then on the second one, I'm going to take two of the four portions. So this is one, and then this is also one. I hope you do see that. Now let's try and then write these out. So as you can see, the very first one is going to be 1 out of 2. 1 out of 2 because we have what? 2 divisions and we have taken just one of them. On the other hand, this here is going to be what? A 2 out of 4. Now, do these two look different? Looking at what we have remaining, as you can clearly see, they don't look different. That is why equivalent fractions represent the same part of a whole. You see? So this part here is the same as this part over here. Let's take one more example so we can appreciate what we are studying. For this example here, I'm going to use a square. So this is my square here. And also for this, we are going to get the same thing just as the previous one. So for this very first one, I'm going to divide it into two equal parts. Let's also divide it into four equal parts. Then for this here, I'm not going to divide into 4, but then I'm going to divide into more than 4. So this here has been divided into 4 equal parts. Whereas this, on the other hand, we have 1, 2, 3, 4, 5, 6, 7, 8 equal parts. So on this very first one, what I'm going to do is I'm just going to take one portion of what we have divided. So let's see how that is going to be. So I'm taking out just one portion, as you have seen here. Then this, on the other hand, I'm going to take two portions of my divisions. So I'm taking this here and then this here. So I'm shading them out. That represents my 2 portion. Now if I want to write the fractions that has been represented here, you're going to realize that for the very first one, we divided it into what? 4 equal parts. 1, 2, 3, 4. So we divided it into 4 equal parts. And how many portions did we take? We took just a portion. For this, on the other hand, we divided it into 8 equal parts. And how many portions did we take? We took 2 out of the 8. But we can see that their representations look actually the same. You see, they all look the same. To the extent that if I'm to pick this here and then put on this, we are going to get the same thing. I hope you do see that. So this was the second one. If I'm to put it on this, we are going to get the same thing. The same way, if I'm to pick this here and put it on this, we see no difference in terms of the remainder, the unshaded portion. So basically, this is what we have to know on what equivalent fractions. So now that we know their representations, let's look at how to find equivalent fractions. So that if I give you one fraction without drawing, you can do what? Find other equivalent fractions or other forms of the fraction I have given you. Let's take a look at that. Okay, so let's look at finding equivalent fractions. Finding equivalent fractions. How do we find equivalent fractions? Now, to find equivalent fractions, all you need to do is to multiply or divide the numerator and the denominator by the same number. We have to multiply and divide the numerator and the denominator by the same number. So let's pick some examples and see how we go about them. We want equivalent fractions of what? 1 over 2. We want other equivalent fractions of what? 1 over 2. So all we want to do is multiply 1 over 2 by any factor at all. Easy. So for 1 over 2, we can choose to multiply it by what? 2 over 2. Easy. Or in other, so for 1 over 2, we are going to multiply the numerator by 2 and also multiply the denominator also by 2. That is, if you choose your number to be what? 2. And in this case, we are going to get what? A 2 on 4, or 2 over 4. And we can say 2 over 4 is equivalent to 1 over 2. How do you know that? If we draw that, you can clearly see that it is. Let me quickly draw so we see. So as you can see with these representations over here, this here is 1 over 2. That is our 1 over 2. And this, on the other hand, which has 4 divisions. How do we know it has 4 divisions? So as you can see, this is 1, 2, 3, and then 4. Right? And how many have we shaded? We have shaded 2 of them. So 2 over 4. Their representation shows they are the same. You see, just by multiplying by 2, this is what we've gotten. You can multiply with any number at all. So far as you are multiplying both the numerator and then the denominator, you are still going to get your equivalent fraction. So we did say 1 over 2. Let's choose to multiply it by a 3. And let's see the outcome. So we still have 1 over 2. And this time around, we are choosing to multiply both numerator and denominator by what? By 3. So I'm going to multiply 1 by 3 and multiply the 2 also by a 3. And by doing so, our numerator is going to give us a 3 over 2 times 3 gives us what? 6. Hence, we are saying that what? Both the 1 over 2 here and then the 3 over 6 here are what? Equivalent. Let's look at their representations and then we see if they are really equivalent. So as you can see with these over here, we have divided the very first one into what? 2 equal portions. And for the second one, we have also divided it into how many portions? 1, 2, 3, 4, 5, 6 portions. So for the first one, we are going to take just a portion of it. So that is what we are doing here. We have taken 1 out of the 2. Then for the second one, we are taking 1, 2, 3 out of the 6 portions. So 1, 2, 3 out of the 6 portions. And as we can see, they actually look the same. All right. So this first one here is going to be our 1 over 2, just like the first one. And then this, on the other hand, is going to be what? The 3 over 6. And they look the same. Right? So this time around, let's take any other fraction and then we are going to use any number as well. So for example, 3, let's take the fraction 1 over 3. And we want another equivalent form of 1 over 3. Well, let's say we want an equivalent fraction of 1 over 3 whose denominator is, let's say, 15. Whose denominator is 15. So we have it's giving us 3 times what gives us 15? We know 3 times 5 gives us 15. So if we want the denominator to give us 15 and we are going to multiply the denominator by 5, then it simply means we should multiply the numerator also by what? 5. And as you can see, 1 times 5 gives us a 5. Whilst 3 times 5 gives us a 15. And we can say that both fractions, 1 over 3 and then 5 over 15, are what? They are equivalent. They are equivalent. I would draw that for us to see as well that they are what? Equivalent. 15 equal. So these are the two fractions we are going to use. We have 1, 2, 3 for the 3 portions. And for this, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So for the 15 portions. Then for the 3 portions, we just need 1 portion taken. As you can see, we have taken just 1 portion out of the 3. For this second one here, we are taking 5 of the portions. So 1, 2, 3, 4, 5, and then let's shade that. You see? So how different does all this look? They actually look the same. Looking at what we have shaded out, they are looking the same, especially the remainders. All right, such that if I'm to take all of this here and fix it on this, you see they look quite the same. You see how they are? Yes. So these are equivalent fractions and how we can find others. Initially, we said that we can get them by both multiplying and then doing what? Dividing. So let's try some of the divisions as well, and then let's see how they also look like. So for this example here, let's take 10 over 50. And we want equivalent fractions of what? These. So for the very first one, let's divide. So you can choose to divide by 2. If we are dividing by 2, you should divide both numerator and denominator by 2. That is 10 divided by 2 over 50 divided by 2. And 10 divided by 2 gives us a 5, whereas 50 divided by 2 gives us a 25. So we can say 10 over 50 is equivalent to 5 over 25. The same way, we can also choose to divide by another number. So if we are dividing by, let's say, 10, that is, we divide 10 by 10 and also divide 50 as well by 10. We know 10 divided by 10 gives us a 1. 50 divided by 10 also gives us a 5. So 10 over 50 is as well equivalent to what? 1 over 15. The cycle of equivalent fractions can go on and on and on and on. So for instance, if we have this same 10 over 50, we can first of all choose to divide by what? Before we continue, you know this sign here, this is an equality sign. The sign for equivalent is 1, 2, 3. Is it we use 3 of these dashes. So we are going to employ that over here to write these equivalent fractions. So for 10 over 50, we can say it is equivalent to what? If you want to divide, if you are going to divide, let's first of all divide by 2, just as we've done here. So 10 over 50 is equivalent to 5 over 25. This same 5 over 25 is equivalent to, if you want to divide by 5, we are going to get what? 5 divides itself once, and it divides 25 how many times? 5 times. You see how they link? So 10 over 50 is equivalent to 1 over 5 as well, and then it's also equivalent to what? 5 over 25. I hope that makes sense. The same way, if we are to pick any other number, this time around, let's pick a bigger one. So 50 over 75. 50 over 75 is equivalent to, if we have to use the division, let's divide by 25. So if we divide by 25, that is 50 divided by 25 gives us 2. And 75 divided by 25 gives us what? 3. So 50 over 75 is equivalent to 2 over 3. The 2 over 3 we have here, if we want to multiply by 2, 2 times 2 gives us a 4, and 3 times 2 gives us a 6. So it is also equivalent. So this same 50 over 75 is also equivalent to 4 over 60. So the multiplication and then the division can all go hand in hand to look for your equivalent, fractions. On that note, I'm going to give some examples or some exercises so you try on your own. So here are our exercises. You have to try the following. Convert 4 over 8 to an equivalent fraction with a denominator of 16. Convert 5 over 10 to an equivalent fraction with a denominator of 20. And then convert 9 over 12 to an equivalent fraction also with a denominator of 4. We have come to the end of this video, and this is Hub Beyond Numbers, where we learn maths the easy way. If this video has been helpful, kindly like, and then if this is your first time, you can also choose to subscribe. Thank you for watching, and I do hope it was helpful. In our next session, we'll be looking at simplification of fractions. We'll be looking at simplification of fractions. So stay tuned even as we treat that. Stay blessed.